So today in the next topic we are going to see storage and recall algorithm. Storage and recall algorithm. So what is meant by storing? What is meant by recalling? Storing is nothing but if you want to place some information within some specified location, then that is nothing but storing. So that can be done in computers or in human brain or in also artificial neuron models. Suppose you are performing some task and you want to store or you want to place that outcome of the task in some memory location, that is called as storing. So what is meant by storing? Placing some information in a memory location. Placing some information in a memory location is called as storing. What is meant by recalling? Recalling is nothing but taking stored information. So recalling is nothing but taking that stored information from a memory location in order to perform some task is nothing but recalling. So this storing and recalling will be done in any of the systems, like it will be done in a normal computer, it will be done in a normal human brain, or it will be done in artificial neural network, which is the combination of human brain and a normal computer. So storing is nothing but placing some information in a specified memory location. Recalling is nothing but obtaining that stored information from a specified memory location is nothing but recalling. Now, how it is done in a neural network? So let us consider a simple single layer neural network consisting of 4 inputs x1, x2, x3 and x4 and an output layer consisting of an output of y. This x1 is passed into y through a weight of w11. x2 is passed into y through a weight of w21. x3 is passed through a weight of w31 and x4 is passed through a weight of w41. And what will be the operation we will do in a neural network? This x1 is passed through a weight of w11. So what is your input here? x1 multiplied with w11 plus, so you need to calculate xnet here, x2 w21 plus x3 w31 plus x4 w41 is your xnet. Now what will you do? You will send this xnet through some activation function. Let us consider we are going to use a sigmoidal activation function. So what is the function of sigmoidal function? Y is equal to f of x is equal to 1 by 1 plus e power minus x, and here you will substitute it as xnet. So y is equal to 1 by 1 plus e power minus, what is your xnet? w1 x1 w11 plus x2 w21 plus x3 w31 plus x4 w41. is your y. Now after calculating y, which is f of x, which is equal to 1 by 1 plus e power minus x net, this is your obtained output of the neural network. Now you will store this net in some specified memory location. So you will store this output of the neural network in a specified memory location. Now after some time you need to recall this output into some other neural network or into the same neural network. Let us consider you are recalling into the same neural network after some time as one of the input. So what will you do? You are going to recall this stored output from the memory location and fed it as one of the input to the neural network, and again calculate new output of the neural network, and that is called as storing and recalling in an artificial neural network. So you will recall that output, and then that output is again fed as one of the input through a weight of w dash, and then again calculating new output of the network. So that is called as storing and recalling in an artificial neural network. So what will you do now? Y is fed as one of the input through w dash, nothing but you are recalling obtained output as one of the input to the neural network. Now again you need to perform numerical computation of the system. So what will you do? You need to find xnet first. So for xnet, what are the inputs? x1 w11 plus x2 w21 plus x3 w31 plus x4 w41 plus, in addition to that, what is your other input? Y is fed as one of the input through w dash, and you can also write xnet is equal to x1 w11 plus x2 w21 plus x3 w31 plus x4 w41 plus w dash into what is your y? 1 by 1 plus e power minus x net. So this is your new net. So I can write it as x net dash. New net of the system after passing obtained output as one of the input by using recalling function. So obtained x net dash, now it is again passed through activation. So you get y dash is equal to f of x net dash is equal to your f of this total value. You are going to pass this x net through this function, then you will get output as y dash 1 by 1 plus e power minus x net dash. So this is called as storing and recalling in a neural network. Let us consider another example. So I am considering x1, x2 as two inputs, y1, y2 as two outputs of the network. x1 is passed through w11, x1 is passed through w12, x2 is passed through w21, and it is also passed through w22. So you are getting two outputs of the neural network as y1, y2. So y1 is obtained by passing x1 net through activation function. y2 is obtained by passing activation function. So first we need to calculate x1 net. So what are the two inputs here you are getting? x1 net is equal to x11 w11 plus x2 w21. This is your first x1 net. Then again you need to calculate x2 net. x2 net is equal to x1 w11 122 plus x2 w2. After obtaining x1 net and x2 net, you need to find y1, which is f of x1 net. Again you are going to use sigmoid activation function 1 by 1 plus e power minus x1 net, which is equal to 1 by 1 plus e power minus x1 w11 plus x2 w21. Next you need to find function of y2, which is f of x2 net, which is equal to 1 by 1 plus e power minus x2 net, which is equal to 1 by 1 plus e power minus, what is your x2 net? x1 w12 plus x2 w22. So this is your final outputs of y1 and y2. Now you are going to send this, you are going to store this y1 in a memory location of h1, y2 in a memory location of h2, and you are storing that information in some memory locations which are specified as h1 and h2. Now after some time you need to recall to some other network. Let that network be x1, x2 having an output of y. You need to recall this y1 as one of the input, y2 as one of the input. The same way for x2 also you need to recall both the outputs. And this x1 is passed through weight of w11, x2 is passed through weight of w21, and y is the output of the neural network. Now in addition, so you need to find x1 net of this neural network, which is having a weighted input of x1 w1 11 plus, in addition to that, you are having two values of y1 and y2 as one of the inputs to the neural network. So y1 into, let the weight be w dash 1 dash, weight be w2 dash, y1 into w1 dash plus y2 into w2 dash. This is your x1 net. You need to find y1, which is f of x1 net, which is equal to 1 by 1 plus e power minus x1 net, which is equal to 1 by 1 plus e power minus x1 w11 plus y1 w1 dash plus y2 w2 dash. This is your y1. Now you need to find x2 net, which is equal to x2 into w21 is one of the input plus again the two inputs y1 and y2 are fed as one of the inputs to x2. So y1 into w1 dash plus y2 into w dash. Now what is your y2? 1 by 1 plus e power minus x2 net, which is equal to 1 by, so here you are having only one output. This is the case for two outputs. If you are having only one output, how will you calculate y? F of x net. What is your x net? There you get x net. x1 into W11 plus x2 into W21 plus, this is having two inputs, y1 into W1 dash plus y2 into W2 dash is your new x net for new set of input. Now, what is your y? 1 by 1 plus e power minus x net, 1 by 1 plus e power minus x1 W11 plus x2 W21 plus y1 W1 dash plus y2 W2 dash. This is your new output by sending this information to the new network. So this is how, let us again see the network. Here we are having two inputs x1 and x2 and two outputs are y1 and y2. This x1 is being sent with a weight of W11. x1 is also being sent as one of the input through a weight of W12 to y2. The same way, x2 is being sent as one of the input through W21 to the first output, and x2 is being sent as one of the input through a weight of W22 to the second output. After passing this, you are going to find x1 net and x2 net. What is your x1 net? x1 W11 plus x2 W21. This is your x1 net. And what is your y1? F of x1 net, which is 1 by 1 plus e power minus x1 net, which is its value. Now, this is again first output of the neural network. You need to calculate second output of the neural network. How will you calculate y2? F of x2 net, which is 1 by 1 plus e power minus x2 net. What is your x2 net? x1 W12 plus x2 W2. This is your x2 net, which is passed through the next function. Then you will calculate output of y2. Now, this y1 and y2 are being stored in memory locations, some memory locations. Let the memory location be h1, one of the memory location be h1 and other memory location be h2. Now, let us consider other network. After storing this, let us consider other network which is having two inputs of x1, x2, which calculates output of y. This x1 is passed through a weight of W11, x2 is passed through a weight of W21. Now, what will you calculate? You need, as there is only one output of that neural network y, you will have only one x net, and that x net will have this information, it will have this information also. So what will you have? X net is equal to x1 W11 plus x2 W21. In addition to that, you are passing this y1 through a weight of W1 dash as one of the input, and also passing this y2 through a weight of W2 dash to this. Now, you need to add both the inputs. Now you are recalling outputs y1 and y2 through a weights of W1 dash and W2 dash from the stored location of H1 and H2. So you are recalling information of Y1 and Y2 through the weights of W1 dash and W2 dash into the network as two inputs. So in addition to that, X1 W11 plus X2 W21, you are going to add Y1. So now you are recalling Y1 through a weight of W1 dash as one of the input to this network, and Y2 through the weight of W2 dash into this network as second input. Now, what is your XNet? X1 W11 plus X2 W21 plus Y1 W1 dash plus Y2 W2 dash. Now, this XNet is being passed through the function which generates an output of Y. Now, again, this Y will be stored in some memory location of Q. Now, after some time, again you are performing this neural network, you can use that information which is stored in Q, or if you want to design a new network, there also you can use this output as one of the input. Suppose you are storing that Y in Q. After some time, you are designing a network having an input of X and output of Y through a weight of W. And here you will calculate XNet, which is X into W plus some information. What is that information? That Y through W dash is being added as one of the input to this network and calculating XNet. Now, this is again passed through activation function, generates output of Y, which is f of XNet, which is equal to 1 by 1 plus e power minus XNet, which is equal to 1 by 1 plus e power minus, what is your XNet? X into W plus Y into W dash, by recalling this information which is being stored in a memory location of Q. So this is how storing and recalling will be done in a neural network. So this is called as storage and recalling algorithm in a neural network, which is one of the topic in third unit. So here we have seen a single layer. We have implemented this storage and recall network for a single layer neural network. We can also go with multi-layer neural networks also. We can implement the storage and recall algorithm for multi-layer neural networks also. So you can consider number of layers. You can store the output in one memory location, again recall that, and you can execute a new neural network, or you can even use that outputs as one of the input for this existing neural network also. This is called as storage and recall algorithm.